Hi, in this video we're going to talk about analyzing your spray CIP performance. Verification forms an important part of any CIP system, CIP standing for clean in place obviously, and over the next few minutes I'm going to go through some of the questions that you should be asking yourself if you've got a spray CIP type system. So one of the first questions you should be asking yourself is, do we check that the CIP preparation is done, the appropriate make or break connections, the manhole areas are washed, proper draining of the vessel? Is this checked via manhole for tankers, for example, or do we check the return holes? The next question you should be asking yourself is, are we familiar with and do we refer to the CIP preparation training modules on an ongoing basis? The next question, pre-rinse, do we check the appearance of the final burst rinse? Is it clear or is it hazy or opaque? Normal rule is to flush until the discharge runs clear. If it's running hazy, if it's running opaque, that's normally indicating a system that's not running at optimal range. If it's not clear, obviously indicating that there's a problem as described earlier. The next question you should be asking yourself is, pre-rinse and wash during CIP, do we check for valve pulsing, such as the tank outlet valve and the air operated valves in line to ensure that both sides of the plunger and stem are getting clean? There is an indicator shaft on top of the valve, so you can tell if the valve is open or closed, and you should be checking this as part of your CIP. The next question you should be asking yourself is, pre-rinse and wash, do we check the pressure on the charts or the discharge side pressure gauge of your CIP supply pump? If the CIP has a flow meter, do we check the flow meter output via your PLC or computer screen if it's a PC based system? Remember, CIP spray patterns might be difficult or impossible to check during CIP, so check that the spray pattern indirectly by observing the vessel after the CIP program is complete. Flow might be needed to be checked with a portable flow meter, for example. The next question you should be asking yourself is, during the wash and rinse cycle checks, are you checking the temperature? Do we check the time at temperature and maximum temperature? It's really important to note that we recommend that you use a portable digital probe thermometer to confirm the accuracy of your recording chart. The next question you should be asking yourself when it comes to your spray systems is, do we check the concentration of the cleaning solution during the circulation of your CIP? This may be done at various time points to check the consistency. You're checking the titrate, causticity, chlorine, the acidity. It's important to note that for some pieces of equipment it's necessary to check the cleaning or the cleaner concentrations multiple times during your cleaning cycle, as this can vary. For instance, on the UF membrane system, chlorine concentration is an indicator of system cleanliness. So if the chlorine residue keeps dripping or dropping, it's an indicator that there is potentially still soil in the system, and the additional chlorine should be added until the chlorine residue stabilizes, which then indicates that the protein soil has been removed. So those are a few things that you do need to consider. It's important to note, unfortunately, quite frequently operators do not test cleaning solutions. So do keep that in mind when you're verifying performance of your spray systems. The next question you should be asking yourself is, do we check for proper flow balance, supply and return? Do we check for the excessive foaming? Check that the pre-rinse and the other rinses are adequate. Foaming normally affects spray efficiency and pumping efficiency and may need to be considered. You might have to add a defoamer, for example, to reduce this risk. Another question you should be asking yourself is, do we observe alkaline and acid post-rinse systems. Do we check that the post-rinse is clear to the drain at the end of the step to ensure that proper rinsing, check conductivity and or pH, and compare that the CIP rinse water soaks. If it's not clear or has a high conductivity or pH, that can indicate a problem with your CIP return pump, for example. Another thing is make sure that the chlorine residue has been eliminated at the end of your alkaline post-rinse. You're always using a test kit and you're checking for at least 10 or less than 10 parts per million in terms of your chlorine. Do we check, your next question will be, do we check to see if the chlorine residue or residual is present at the in the acid wash solution, and alkaline post-rinse has negligible chlorine, then obviously if you do, it's indicating a leaky valve or other mechanical problem might exist. This can obviously lead to corrosion issues for obvious reasons. Another question you should be asking yourself is, during the CIP, do we check the functioning of the CIP system? For example, proper valve opening and closing. Are you noting any observable mechanical issues? Another question you should be asking yourself is, do we check sanitizer concentration? Determine an appropriate sample point that is representative of your sanitizing solution and check against it. Another question you should be asking yourself is, do we check if the final drain is complete? Is there water remaining in the vessel or on the return lines? It's important to note that the program, correct time if needed, make a note of your total cleaning time and verify that this is accurate. Another question you should be asking yourself is, when this is done, are you observing the cleanliness of the vessel? Check for soiling due to partially plugged or blocked spray balls. So that's a whole series of questions that you should be asking yourself when it comes to spray systems and verification.
Keen to build your skills? In terms of a training investment benefit and analysis, here's how our training stacks up. Training helps reduce increased chemical usage and cost. Reduces increased microbiological hygiene risk to product. And increased non-conformance risk and associated poor product quality cost. If you are new to New Zealand's food safety standards, you would be reassured to know global regulators such as the FDA recognizes New Zealand's regulatory systems. It is a founding member of the global organization Codex Alimentarius, part of the World Health Organization, and New Zealand chairs the Codex committees that set global standards for milk and dairy products, CCMMP, and meat hygiene, CCMH, both best practice guidance bodies that FoodSafe has experience with and whose standards are embedded into all our training. FoodSafe's training helps companies meet GFSI requirements by ensuring employees with low confidence and understanding are both coached and trained. By including lessons learned both from within and from other businesses, we train across sectors, and by ensuring current and emerging food safety hazards are communicated to all employees. FoodSafe's quality assurance systems include a third-party independent audit and registration by the New Zealand Qualification Authority or NZQA, a Category 1 NZQA review status as a private training establishment, New Zealand's highest training provider standard, and we ensure our training is instructor-led and delivered by a trained ISO 9001 and 22000 lead food safety auditor, which brings us to our service delivery and customer reviews. Verified trainee reviews. Sample period 10 years plus. Number of reviews over 827 and counting. Review average 4.9 to 5.0. So, book yourself and your team in now. We would love to train you. We can deliver this training to you, on-site, at your company or, instructor-led, over video conference, right across the world. food safe. Training solutions and services for high-performance people and food companies.